Today we will see a different method of finding the solution of second order differential equations. This technique is called as the method of variation of parameters. Okay, so there are several set of differential equations which cannot be solved using the earlier method we were discussing. Okay, so such problems can be solved by using this particular technique. Okay, so let us consider a differential equation. Consider a differential equation, say y double dash plus some constant into y dash plus some other constant into y is equal to a phi of x, right? We know that here the a1 comma a2, they can be either function of x or they can also be the constants. Okay, now we try to get the yc, the complementary solution of this particular equation. Okay, so what we do, we first find the complementary solution of y double dash plus a1 y dash plus a2 into y equal to 0. We will solve this and we'll get the complementary solution. Okay, so this means we are going to get in the following fashion, that is yc is equal to a constant c1 into y1 plus c2 into y2. Right, here c1 and c2 are the constants and the y1 and y2 are some other functions of x. c1 comma c2 are constants, y1 comma y2 are the functions of x. Okay, now our intention is to get the complete solution from the yc itself. We don't have to find the yp. The particular solution is not required, right, to be found here. So what we do, we directly go ahead and convert this into the y. Okay, so from yc we can get y, right? That is y is equal to, look at the previous equation, wherever we had a constant we are going to replace it by capital A. Now I see this is a, this is a actually is a function of x now, so this could be capital A times y1 plus some b into y2, where this a and b are the functions of x. All right, so where a and b are the functions of x, in the sense I need to find them. So how to find that? We can use the following equation. So a is equal to this is negative integral of whatever y2 I had, that y2 into RHS of the given equation, that is phi of x, divided by, we have to find a value called w. I'll tell you what value is w later, into dx plus some constant k1, because after integration you are going to get a constant. Similarly, b is equal to, this is a positive quantity, so positive integral of y1 into the phi of x divided by w times dx plus another constant k2, and we have a term w over there, so let's try to find the w. So w is equal to, this is equal to y1 into y2 dash minus y2 into y1 dash. So y1 and y2 we already have from the yc. In the yc itself we will observe what are y1 and y2. We need to differentiate that to get y1 dash and y2 dash. We are supposed to use them in the equation to get the w. So use that w in a and b equations. Once you obtain this, put it back in the previous equation, y is equal to capital A times y1 plus b times y2 to get the complete solution. So here we can actually get the answer pretty much straightforward and in a very easy way, rather than finding the yc and yp separately. Okay, so that's the technique. Anyway, when we solve, this becomes more clear to you, right? So solve by using method of variation of parameters. That will be the questions. So this is the first problem that we are going to solve. Y double dash plus a square into y is equal to secant of ax. All right, so by default we will convert this into the required format including d. So replacing d by dx as capital D, I'm going to get d square plus a square, multiply this with y, is equal to, this is secant of ax. All right, so now I need to find the yc first. To find yc, what I'm supposed to do, I will write the auxiliary equation. Auxiliary equation is nothing but replace d square by some variable m square plus a square equals to 0. All right, so we know that the m square becomes minus of a square, so m is equal to plus or minus j times a. These are the roots. Okay, this means roots are complex conjugates. As soon as we see this, we can write it in the following fashion. That is, the yc is equal to, no real part, so no e to the power. I'm going to get a constant c1 into, this is cos ax, plus another constant c2 into sin ax. So this is the yc. So now recall the steps of that we have discussed earlier. So the steps are, once you have the yc, right? So you see here we are in this step where we have the yc with us. Okay, once we have the yc, now I am going to observe the constant and the functions of x. So wherever I see the function of x, I'm going to call them as y1 and y2. Okay, that's my next step. And also I'm going to convert this yc itself directly into y. So we can see that we had a yc here. I'm going to convert that into the y here. How? y1 y2 remain same. Instead of writing this c1 and c2, I'm going to write capital A and capital B. So once I have the capital A and capital B with me, I can simply substitute the values by using their equations, get the values of A and B, put it back. So that's how we try to obtain all the values of unknowns like A and B. Okay, so that's our next procedure. So what I'm going to do now, I'll directly convert this into y. So using variation of parameters, right? Variation of parameters, I can convert yc into y as this. Y is equal to sum a times, this is cos ax, b times sin ax, where I can see that my y1 is equal to, so I'll call this as equation number 2. Later on I will substitute here. So y1 is cos ax, y2 is equal to the second function, that is sin ax. I need y1 dash because I remember I have to calculate a w. So this is y1 dash, differentiation of cos is negative, so minus a sin ax. y2 I need y2 dash. How do you calculate y2 dash? Differentiation of sin ax is a cos ax. Okay, then I need to calculate a w now. So let's calculate the w. W is equal to, this is y1 y2 dash minus y2 into y1 dash. So that is y1 into y2 dash will give you cos ax into cos ax, that's cos squared, there is a into, this is cos square ax, then minus y2 into y1 dash, y2 into y1 dash, there is a minus term, so this becomes positive, a into sine square of ax. So I know that this can be written as a into, this is cos square ax plus sine square ax. I know that cos square theta plus sine square theta is equal to 1. So the w is nothing but, w is simply a. I got it. Also, I need the phi of x to be substituted in the function, in the equations of a and b. So let me write down what was that. The phi of x, if I look at the given question, that is the right hand side of the given question, it's a secant ax. So I just have to write the phi of x is equal to secant ax. So use all these values to calculate the values of a and b. Okay, so now let's go for that. So if you remember, the equation of a is nothing but, this is minus integral of y2 into phi of x divided by w into dx plus some constant k1. So let's substitute, this is minus, I need y2, if you look at y2, y2 is sine, this is sine of ax, into phi of x, this is secant ax whole divided by w, which is a dx plus k1. Okay, so now this becomes equal to, this is minus 1 by a integral, there is sine ax whole divided by secant ax, I'll bring it to the denominator as cos ax dx plus a constant k1. Okay, so this means the whole function becomes equal to 1 over a integral, sine by cos is tan, so this is tan ax dx plus a constant k1. So we know that the tan ax integration is minus, anyway already I have a minus, so tan ax is log of secant ax whole divided by a, so there is already one a available, so this becomes a square. So minus log of secant ax whole divided by a square plus k1. So this will be the value of a. Similarly, now I need to calculate the value of b. So from the equation, we know that b is equal to, this is integral y1 into phi of x whole divided by capital W times dx plus a constant k2. Okay, so now this means I can simply substitute the values. This is integral. Y1 is cos ax. Okay, phi of x is secant ax divided by a times dx plus k2. So if you remember, they are cos and secant are inverses of each other. So they will cancel each other. This is 1 by a integral dx plus k2. So integral of dx is simply x. So this is x by a plus a constant k2, that is b. So substitute a and b values back into the equation number, I think 2, yeah. So equation number 2. So what we do, we'll give the values of a and b as some number. So this is, say, equation 3, and let's say this is equation number 4. So what I'm going to do now, put 3 and 4 in equation number 2. This is going to give the following as the final answer. Okay, so that is y is equal to, see, I have to put the value of a first. A times cos ax plus b times sin ax was there in the equation 2. So a is nothing but we obtain this as a, that is minus log of secant ax whole divided by a square plus a constant k1. This is a into cos ax. That's the first term, plus I should write a b now. So b is equal to, this is x by a plus k2 into, this is sin ax. So that's the final answer. Okay, now let's proceed to the next problem. All right, so the question here is d square y by dx square plus y is equal to, this is tan x. We'll convert this into the required format. That should be d square plus 1 into y is equal to, this is tan x. Our first objective is always to find the yc. So in order to find the yc, what we'll do, we write the auxiliary equation. The auxiliary equation is nothing but replace capital D by m. So this is m square plus 1 equal to 0. So this implies the m, we are going to get this as plus 1 goes to other side, so minus 1. Root of minus 1 is plus or minus j. So as the roots are conjugates, we can write the yc as a constant c1 into, this is, say, cos ax, a is 1, so cos x plus c2 into sin x. All right, now this means using the variation of parameters, method of variation of parameters, the final answer y is equal to a times cos x plus b times sin x. Say this is equation number 2. Now, in order to find the a and b, we need some other functions like say y1. y1 is equal to whatever is next to a, that is cos x. And the y2 is what is next to b, that is in this case sin x. All right, then we need y1 dash. Differentiation of cos x is minus sin x, and the y2 dash looks like differentiation of sin x, that is cos x. Okay, then we need w. W is nothing but this is given by the equation y1 into y2 dash minus y2 into y1 dash. So in this case y1 into y2 dash will be the cos square x minus, so minus of minus will be plus sin square x. Cos square theta plus sin square theta is 1, so w is nothing but 1 in this case. All right, also the phi of x given in the problem is tan x. So using all these values, now we can definitely obtain the values of a and b as follows. So a is given by, this is negative integral y2 into phi of x whole divided by w dx plus a constant k1. Okay, so this is equal to minus integral, the value of y2 is y2 is sin x, this is sin x into this is tan x whole divided by 1 times dx plus a constant value k1. Okay, so this is equal to minus integral sin x into this, I'm going to write sin x by cos x dx plus k1. So we can do only one thing here. Let me write the sine into sine. This is sine square x by cos x dx plus k1. What we do? Sine square theta and cos theta I have in the denominator. Okay, let's try this. This is integral. I'll substitute for sine square theta. Sine square theta is 1 minus cos square theta whole divided by this is cos x dx plus a constant k1. So this is equal to negative integral 1 by cos x is actually secant x, and cos and one of the cos will cancel, so that is 1 cos x, secant x minus cos x dx plus k1. I can write this as minus, I'll take inside. This is simply the cos x minus secant x dx plus k1. Yes, now we have the answer. So this is nothing but first term is integration of cos x, that is sin x, minus integration of secant x. If you remember, integration of secant x is a standard function, that is log of secant x plus tan x. That's what is integration of secant x plus a constant k1. This is a. All right, similarly, now let us calculate b. So recalling the equation of b, we get b is equal to, this is integral y1 into phi of x by w dx plus k2. All right, so let us substitute. This is equal to integral. The y1 was cos. This is cos x. Phi is a tan x divided by 1 times dx plus k2. So this is equal to integral cos x sin x by cos x dx. So this cos cancels plus k2. So now we can see that this is a straightforward integral, integration of sin x. Okay, integration of sin x is minus cos x plus k2 is equation of b. So we'll call the value of a by equation number 3, and this particular value, that is b, as 4. So 4 and 3 in equation number 2. When this means I am actually trying to substitute back. Okay, so when I'm substituting back, I'm going to get my final answer, that is y is equal to a. I should write a. So a is nothing but this is sin x minus log of secant x plus tan x plus k1. This should be multiplied by cos x. This is a cos x plus, I should write a b now, so b is minus cos x plus k2 times sin x. So earlier we had a cos x plus b sin x. We found the values of a and b and we substituted, and this is what is the result. All right, let's proceed further for the next problem. Next problem is y double dash plus 4y is equal to tan 2x. Okay, now this means we can rewrite this as d squared plus 4 times y is equal to tan 2x. So that means first objective is to find the yc. So how to find yc? I need auxiliary equation. Auxiliary equation is m squared plus 4 equal to 0. So m equal to 4 goes to the other side as a minus 4. So plus or minus j times 2 is the answer. So as the roots are complex conjugates, I can write yc as a constant c1 into cos 2x plus another constant c2 into sin 2x. So this implies I can directly write the y, which is equal to a cos 2x plus b sin 2x. Okay, so before we find a and b, we need the y1. Y1 is cos 2x. We'll write y2, which is sin 2x. So that means I need y1 dash. Okay, so y1 dash is equal to minus of 2 into sin 2x. Y2 dash is 2 into cos 2x. They are the differentiation of y1 and y2 respectively. Okay, all right. Now let us substitute. Okay, before that we need the w, correct? So how to calculate the w? Let's write the w first. W is equal to, that is y1 into y2 dash minus y2 into y1 dash. So y1 into y2 dash will be 2 times cos square 2x, minus of minus is plus 2 times sin square 2x. I think I made a mistake, so just let me correct this down. So 2 cos square 2x, 2 sin square 2x. So w becomes equal to 2. Okay, and the phi of x, which is given in the right hand side of the equation, that is tan 2x. All right, using all these values, we are supposed to find out the required values of a and b. Okay, so let me start with a. A is given by negative integral of y2 into phi of x divided by w times dx plus a constant k1. So this is equal to, let us substitute, minus integral. So y2 is equal to sin 2x. Phi of x is equal to tan 2x, whole divided by the w value is nothing but 2 into dx plus k1. All right, so this means this is equal to, I'll take the sine into cos, we have sin 2x. Let's make it like the previous problem. I'll take a minus half outside. So this is sin 2x into tan is nothing but sine by cos. So sin 2x by cos 2x dx plus a k1. So this is equal to minus 1 by 2 into, this is sine square of 2x by cos 2x dx plus k1. All right, now I have no other way, but I need to bring a cos in numerator as well as denominator. So for that reason, I'm going to write minus half integral sine square theta is nothing but 1 minus cos square theta whole divided by a cos 2x, right, dx plus k1. So this means I'm going to rewrite this as, this is equal to, I'll take minus inside, so there is a half outside integral, this is cos square 2x by cos, it's simply a cos function, this is cos 2x minus 1 by cos is a secant, so I'm going to write the secant 2x. The minus sign which is outside, I have taken that inside. Okay, dx plus k1. So this is nothing but half of integration of cos 2x is sine 2x by 2 minus we have a secant function, so secant is log of secant 2x plus tan 2x. Since it's a 2x, I should divide the whole thing by 2. Okay, so that closes my bracket plus k1. So the denominator 2 and 2 I can take it out as 1 by 4 into some. Okay, so this is the A. Now I'll calculate the B. So let's call this is equation number 3. So to start with, B is equal to, the equation says integration y1 into phi of x by w dx plus a constant k2. So that means this is equal to, let us substitute the values. The integral y1 is cos 2x, the phi of x is tan 2x, whole divided by the value of w is 2, so dx plus k2. Alright, so this is equal to half integral cos 2x into, this is tan is nothing but sin 2x by cos 2x. So this will cancel, dx plus k2. So that means this is integration of sin 2x. So there is half integration of sin is nothing but minus cos 2x divided by 2 plus k2. So this is minus cos 2x whole divided by 4 plus k2 is the value B, which we call as equation number 4. Alright, once we have this, our final answer y is equal to, therefore equation 2 becomes y is equal to a times cos 2x. So a is nothing but, this is sin 2x minus log of secant 2x plus tan 2x divided by, there is a 4 outside, I'll take it inside. Okay, this plus a constant k1 into cos 2x. This is a cos 2x plus, I need to write a b. So b is equal to minus cos 2x divided by 4 plus k2 into, sorry, not cos, it should be sine. This is sine 2x is the final answer. Let's go to the next question. And the next question is d square y by dx square minus 2 times dy by dx plus 2 times y is equal to e to the x into tan x. Okay, so this means d square minus 2 into d plus 2 times y is equal to e to the x tan x. So our first intention is to find the yc. So what we do, we write AE, that is m squared minus 2m plus 2 equals to 0. So m is equal to minus of b, that is 2, plus or minus root of b squared 4 times divided by 2. Okay, so this is equal to 1 plus or minus j times. So root of 4 is 2, 2 by 2 is 1. So 1 plus or minus j is the answer. So when we have roots as complex conjugates, the yc is guessed as e to the power the real quantity, that is 1 into x, into, this is c1 cos of 1 into x plus c2 sine of 1 into x. This is our yc. So after yc, we'll write the similar format for y. Therefore, y is equal to, using the variation of parameters, e to the x, this remains as it is. This is a times cos x plus b times sin x, equation number 2. So observe that we have to write down the required values to calculate the values of a and b. So I need y1. y1 is e to the x cos x. y2 is equal to e to the x sin x. Let's write the y1 dash. y1 dash is equal to, it's a product. So keep the keep the first function as it is, that is e to the x. Cos x differentiation is minus sin x. Then plus, keep the second function as it is, that is cos x. E to the x differentiation, e to the x. So this can be written as e to the x into, I'll write cos x minus sin x. So that's y1 dash. We'll calculate y2 dash. y2 dash is equal to, first function as it is, differentiation of sin x is cos x plus, this is sin x into e to the x. So e to the x into cos x plus sin x. Okay, now in the next step, now we need to calculate the value of w. So w is equal to, this is y1 y2 dash minus y2 into y1 dash. We'll look at those values and we'll substitute. So this is equal to y1 is e to the x into cos x multiplied by y2 dash. y2 dash is e to the x into, this is cos x plus sin x. Then we have minus the y2 is e to the x into sin x multiplied by y1 dash is e to the x into This is cos x minus sin x. So this is equal to, let's multiply term by term. So there is e to the x common. I'll take e to the x into e to the x as e to the 2x into, so we have cos square x plus cos x sin x, then minus cos x sin x, minus of minus is plus sin square x. So this and this term will cancel. Cos square x plus sin square x is 1. So we have the w given by e to the 2x. And if you look at the right hand side of the given differential equation, we have the phi of x is equal to e to the x into, this is tan x. So now let us use all these values and find the a and b. So to find a, this is negative integral of y2 phi of x whole divided by w dx plus k1. So that is equal to minus integral of, if we want to write the y2 is e to the x sin x into, I need phi of x, that is e to the x tan x whole divided by the w is nothing but e to the 2x. Now you can see that these will get cancelled, dx plus k1. So this problem is now very similar to the previously solved step. So where we had minus of sin x tan x, so tan x will substitute sin by cos. So numerator is sin square. Sin square I am going to replace it as 1 minus cos square. So 1 by cos is secant, and cos square by cos is simply cos. So I'll directly write the answer. We already have this answer with us. So this comes to be sin x. This is sin x minus log of secant x plus tan x plus k1. So that is the A. Now let's calculate the B. So B is equal to integral, this is y1 phi of x by w times dx plus k2. So substituting the value of y1 now, so y1 is nothing but e to the x cos x into the phi of x. We already have the phi of x as e to the x tan x divided by e to the 2x dx plus k2. So this will cancel. Now I think cos into sin by cos, cos cancels, so we have only integral of tan x, integral of sin x, so that will be minus cos x plus k2. That is B, equation 4. Right. Now using this 3 and 4 in equation 2, right, we'll substitute the third and fourth equation in 2. Therefore we get y is equal to, there is a e to the x outside into, I'm writing a now, so a is, this is sin x minus log secant x plus tan x plus k1. This into the cos x. plus another, I'll split the e to the x now, otherwise I should use a bigger bracket. So this is into now minus cos x plus k2 times the sin x. So e to the x, a cos x, e to the x, b sin x is the final answer. Alright, now we'll go for another problem. This is y double dash minus 2y dash plus y equals to e to the x log x. So we will convert this into the required format, that is equal to d squared minus 2d plus 1 into y is equal to e to the x log x. Alright, so our first intention is to find the yc. So to find yc, what we'll write? We'll write the auxiliary equation, which is as follows. That is m square minus 2m plus 1 is equal to 0. Okay, I can see that this is a perfect square, so I can write this is m minus 1 the whole square equal to 0. So roots are 1 comma 1. So as I can see, roots are real and repeated. So as the roots are real and repeated, the yc can be guessed as follows. That is a constant c1 plus c2x into e to the power x. Alright, so this implies we can guess the y as follows. So c1 should be replaced by, this is a, plus c2 is b, x into e to the x. So this means what? This is a into e to the x plus b x into e to the x is the, so this is what we call 1. This is equation number 2. So in order to find the values of a and b, we need the other parameters like what is y1? y1 is equal to e to the x. What is y2? y2 is x into e to the x. So what happens to y1 dash? Remains same as e to the x. What happens to y2 dash is, first keep the first function as it is, differentiate, this is e to the x, keep the second function as it is, e to the x, differentiate x, which is 1. Okay, so let's write the w now. So what is w? As the equation, this is y1 into y2 dash minus y2 into y1 dash. So y1 is e to the x, y2 dash is x e to the x plus e to the x minus y2 is x e to the x, y1 dash is e to the x. So that x e to the x e to the x will cancel. So remaining term is e to the x into e to the x, that is e to the 2x. So this will be the w. So once we have the w with us, we need the phi as well. So phi of x, we can observe the given equation. It says that it is e to the x into log x. So that means in the next step, uh, we will write it in the following fashion. Sorry, let me just go back. Okay, so we'll start with the calculation of a. Therefore, a is equal to minus integral of, this is y2 into phi of x divided by w times dx plus k1. So let us substitute. So this is negative integral of minus x into e to the x into, this is e to the x log x divided by e to the 2x dx plus k1. So you can see that e to the 2x will cancel with this. So minus of minus becomes plus. Is it minus or minus? Sorry, there is no minus inside. This was my mistake. So let me erase the outside. Okay, so this means this is equal to, I am supposed to integrate minus of integral, this is log x into x dx plus k1. So the standard method to integrate a product is integrating by parts. So that is equal to minus, keep the first function as it is, that is log x, right? Integrate the second one, that is x square by 2, minus integral of this function x square by 2 into differentiation of log x is 1 by x, right, into dx. This is my integration, plus there is a k1. So this and this will cancel. So this is minus x square into log x whole divided by 2 minus, so integration of x is x square by 2, so there is already a 2, right? And this minus which is outside, when being applied to the inside, this becomes plus. So x square by 2 into 2, so 4 plus k1. Okay, this is the value of a. We'll call this as equation number 3. Then my next intention is to calculate b, which is integral of y1 into phi of x whole divided by w dx plus a constant k2. So this is equal to integral, the y1 is simply e to the x into the phi of x is e to the x log x whole divided by e to the 2x dx plus k2. So e to the 2x will cancel with e to the x and e to the x. This becomes equal to simply log x dx plus k2. So what we do, log x as log x into 1, because we want to apply integration by parts. So that is, this is log x into second function's integration is x minus integral of this x into differentiation of log x is 1 by x dx plus k2. So this cancels. So this is x log x minus, this is x log x minus x plus k2. This is equation number 4 corresponding to b. So therefore we can write the final answer, y is equal to the a times first function, a is equal to minus x square log x whole divided by 2 plus, this is x square by 4 plus a constant k1 times e to the x plus the second function, that is x log x minus x log x minus x plus k2 times x into e to the x is the final answer. So this finishes the concept of solving the differential equation by using method of variation of parameters. Thanks for watching.